Here at the end of the Earth, it still feels like a place for raw exploration and adventure. It's vast in all directions, and ground zero for some of the biggest questions we have about the climate. But when we decided to make a series about the frozen places on Earth, we knew there would be one hurdle we would need to jump over first. What is the cryosphere?
The what?
Ooh.
I have no idea.
While I'm aware of the cryosphere, I don't actually know what it is.
It has something to do with ice. All right, that's all I got.
How do you get people acquainted with the cryosphere when most of us don't even know what it is?
Hey, so here we are in Washington, D.C., standing on the roof of NASA headquarters. That's the Capitol building right behind me. And what headquarters does is kind of serve as the focal point to connect the dots.
That's Dr. Tom Wagner, NASA's cryospheric program scientist at headquarters. In short, Tom is responsible for making sure NASA knows what the current status of the cryosphere is.
The cryosphere is everything from the snow that falls by your house to the icy reaches of the Himalayas, to the big ice sheets of Antarctica all the way at the South Pole, and also the frozen ground of the Arctic, and even some of that frozen ground that's currently under the ocean.
If you had to break it down, you'd have a mix of sea ice, snow cover, permafrost, ice sheets, and glaciers.
Right now, our best predictions are that sea levels will rise anywhere from 1 to 3 feet within the next 100 years. 3 feet of sea level rise has the potential to displace about 100 million people, which is a lot of people that need to find new homes.
Our current reality places us at a near tipping point, and the cryosphere is playing a huge part in that delicate balance.
So one of the things people don't know about NASA is that we study the Earth, and we've been doing that since NASA's inception back in the 1950s. And we study the frozen part of the Earth in a variety of ways.
Missions like SNOW-X, Airborne Snow Observatory, Oceans Melting Greenland, Operation Icebridge, Arctic Boreal Vulnerability Experiment, and countless other labs and individual researchers stand at the forefront of monitoring the cryosphere. But this year was a particularly big year.
3, 2, 1, and liftoff of Grace Follow-On, continuing the legacy of the Grace mission of tracking the movement of water across our planet.
2 state-of-the-art satellite missions are being launched in a single year as part of a major attempt to understand Earth's frozen places. Our scientists are answering hard questions, sharing stories from the field, and giving their best predictions for what we can expect of a warming world. We're taking you with us as we follow NASA explorers on their journey to the frozen ends of the Earth as they study our rapidly changing world from satellites, planes, and boots on the ground.
What we can do really well from orbit is we can tell when a surface of land is covered in snow. What's tricky is though, how thick is that snow? And it's even trickier how much water is in that snow.